Good evening everybody, and once again welcome back to the video. In this video we are going to learn from raw data to insight building lakehouse architecture with Apache Hudi and star schema. So let's see what we are going to do in this project. So we are going to build the following items, right? So we'll have our customer Apache Hudi raw table, we'll have a order table, and then we'll basically create a date dimension, and then we are going to create a fact table which is orders. This is how it looks like. You will have following Hudi tables. You will have a Hudi table for customers, Hudi tables for the orders, a date dimension, and a fact table for orders. We are going to build this entire architecture in this video. Let's get started and let's do this project now. So the first step is pretty straightforward. As you can see, from line 1 to line 25, I'm defining all the imports. Here I'm defining OS, sys, UUID, random, PySpark, a Spark session, Spark context, date time, JSON, Boto3. These are all the imports essentially that I would be needing for the project. So after you have defined the imports, now we need to create a Spark session. This could be done in the following ways. On line number 1, as you can see, I'm submitting a package. I'm using Apache Hudi package 0.12.1 for Spark 3.3. Here I'm creating a Spark session on line 11 to line 16, and then I'm printing the Spark session on line 18. In order to work with the project, we would need some data. We need some fake data. So I have written two helper function, which is going to generate some fake data. Let's take a look at that. Here you can see these are pretty simple Python function. The function name is get customer data. It takes total number of customers, so how many customers you want to generate. And as you can see, I use a library called faker. I'm generating fake customers, and at the end I'm appending into the array, and then this function returns a list of dictionary or list of objects, which is basically customers. Similarly, I have a function for orders as well. This function will generate fake order item, as you can see. So what this function does is basically it will generate an order ID, a name, order value, priority, order date, and customer ID. So again, the job of these two functions is basically to generate some fake data and return list of objects. Now that we have defined a function which is going to generate some fake data, we need to write a function that's going to perform an upsert on a Hudi data lake. Let's see that in action. So here, as you can see, I've defined a function def upsert Hudi table. This function takes a database name, a table name, a record ID, right? Precom key, which is used for dedupe purposes, a Spark data frame, table type is copy on write, method is upsert. So these are the attributes that I will pass into the function, and this function is essentially going to perform an upsert on a Hudi transactional data lake. Now let's see the data frame in action. So I'm going to call the methods and generate a Spark data frame. As you can see, I am calling a function called as get customer data. And here you can see these are the two customer it has generated for me. Similarly, I call a method for order data, as you can see, and this is going to generate a fake data frame for order ID. So now I have two data frame, which is the customer data and the order data. Since I have these two data frame, which is the customer data frame and the order data frame, now I'm going to call the function to perform upsert into the Hudi transactional data lake. This is going to create two Hudi tables, order and customer. Let's take a look at that. Here you can see I'm calling the function upsert Hudi table. I'm passing in the database name as HudiDB, the table name is customer, record ID is customer ID, precom key is created at, which is used for dedupe purposes. I'm passing in the Spark data frame, table type is copy on write, method is upsert. Similarly, I'm creating a Hudi data lake for the orders. So here you can see the database name as HudiDB, table name is order, record ID is order ID, precom key is order date, Spark data frame, table type is copy on write, and method is upsert. Now that we have two Hudi tables, that is customer and order, we need to create a Hudi table for date dimension. Let's see the code on how to create Hudi date dimensions. So here you can see is the code to generate a Spark data frame for a date dimension. On here, min date, this is basically from 2020 to 2025. I want to generate a list of date. Date range, I'm using a library called pandas, and I'm using a method called date range where I pass in the start date and the end date. Once I have the date range, I'm extracting the year, the month, the day, the quarter, the weekday, etc. And then here I'm creating a Spark data frame over here, as you can see. After printing the date dimension, as you can see, this is how the date dimension looks like. I have a data key, a year, a month, a day, a quarter, a weekday, and a weekday number. This is basically my Spark data frame. Now that we have a Spark data frame for date dimension, now let's create an Apache Hudi transactional data lake for a date dimension. I'm simply going to call my function that I wrote, that is upsert Hudi table. I'm going to pass the database name as HudiDB, the table name as datedim, record ID as data key, precom key as data key. Again, precom key is usually used for dedo purposes, so I'm just passing in the same thing. Here I'm passing in the datedim Spark data frame, table type as copy on write, method as upsert. Now I have three Apache Hudi tables, which is customer tables, order table, and a datedim table. At this point, we have essentially created three Hudi tables, which is the customer table, which has customer ID, name, email, phone, and address. We have a order table, a Hudi order table, which has order ID, customer ID, order date, order value, and the priority. And also we have a date dimension, which has a date, a day of a week, a month, a year, a quarter, week number, etc. Now it's time we create our Apache Hudi fact table, which is the fact order table. Now that we are about to create our fact table, now what we are going to do is basically we are going to create three temp views so that we can use Spark SQL and perform joins, and again then use that data frame to insert into the Hudi transactional data lake, which is a fact table. Let me show you what I'm talking about. So here you can see these are the part to my Hudi transactional data lake: customer, order, and datedim. Here I am creating a temp view called customer, order, and datedim. Using this temp view, now I can run SQL queries on this. Now it's time we insert the data into the fact table. Before we do that, let's take a look at the diagram, the select query, and how to insert the data into the Hudi fact table. So again, we have a customer table, we have an order table, and then we have a date dimension. Now we need to insert data into this particular table. This table does not exist. We have to first select the data, grab the data, and then insert it. So let's take a look at the Spark SQL query. So quickly, I'm going to share my screen. All right, hopefully you guys can see my screen. So over here, I'm selecting the order ID from the order table, customer ID from the customer table. As you can see, I'm selecting the customer ID from the customer table, order ID from the order table, order value priority from the order table, and then I'm selecting a date key from a date dimension. So if I scroll up, again, this is the date key, as you can see. Then I'm performing a join on the customer and the order table on the key called customer ID. So if you take a look at the diagram, both the customer and the order table has customer ID. So I'm performing a join on both of these tables. Then over here, I'm selecting the date key, right? So basically I'm selecting this date key, and I'm providing the format because I know my date key is in the format YYYMMDD. And then I'm essentially performing a join on the order date. So if you observe my screen over here, this is the order table, right? So I'm performing the join on the order date, right? And the date format over here is, as you can see here, YYY-MM-DD. So I'm performing the join. So basically, this query will give me data. This will give me order ID. It's going to give me customer ID, a date ID or date key, order value, and the priority, which is our fact table. After executing the query, here you can see this is how the result looks like. I have order ID, I have customer ID, order value, priority, and this is the date key. Now I have successfully implemented a star schema, meaning, let me quickly go to the image. So quickly zooming in. So again, I have a star schema, which means now I can essentially select the order ID and essentially analyze the order on a date dimension. For example, the total order over a year, month over month, year over year, quarter over quarter, week, etc., etc. I can also fetch the customer name, right? I can do all the aggregation now very easily. And at the end, the last step is nothing but once we have these Spark data frame, which is the fact table, now we essentially insert that into the Hudi transactional data lake. So I create the table name as order fact. I provide the record ID as order ID and the customer ID. I'm using a composite key here. For dedupe, I'm just using order ID, but again, you can also use something else like a timestamp. But again, I'm just putting in anything for the pre-com key because again, the combination of order ID and customer ID will be unique always. And here you can see I'm providing the order fact data frame, table type as copy and write, method as observed. With this approach, you have successfully built a lakehouse architecture, a star schema, where you have a customer table, a order table, you have a date dimension, and a fact table, which is your orders. I hope you have enjoyed the video, and all the source code can be found on my blog section. And if you have any further question, do let me know your question in the comment section below. Thank you so much for watching. The best way to learn is to try things out, pause the video, try the code snippets. That's the best way to learn. With that being said, keep smiling, keep programming, and I'll see you in the next video.